Measures of dispersion, and I hope I'm pronouncing that correctly. Our objective: determine the range, the standard deviation, and the variance of a variable from raw data. Well, first off, what is dispersion? It is the degree to which data are spread out, the extent to which a distribution is stretched or squeezed. So basically, it's the spread of the data. Are the data really spread out, or are the data pretty tightly, pretty compact, close to each other? Okay. Generally, we want to know a measure of central tendency, which is the mean or the median for numerical data, alongside how much spread there is in the data. So that generally we describe data with two things. We use a measure of central tendency, mean or median, and then we use a measure of dispersion. How spread is the data? And that gives us a sense of what's happening. Three numerical measures for describing the dispersion are the range, the standard deviation, and the variance. Range, I'm guessing you've seen from a long time ago, back in your math, your maybe even elementary or middle school math. These two might be a little newer words or vocabulary words for some of you. What is range, and what is standard deviation, and what is variance? Range, the difference between the largest value and the smallest value. That's range. Okay, range R equals largest data value minus smallest data value. You're calculating it using only two values, the largest and the smallest. It is not resistant. Okay? If you change the extreme value, because it's largest minus smallest, you change the range substantially. So it is affected by extreme values. Totally makes sense. You change the top value, you've affected the range. You change the bottom value, you've affected the range. That one's the simplest of the three. Standard deviation. How far on average each observation is from the mean. Deviation means how far from the normal. Okay? A low standard deviation is the data are clustered around the mean. So if you calculate standard deviation and you get a small number, you have data that's close to the mean number, you have less dispersion, less spread. A high standard deviation number means the data are more spread out from the mean. You have more dispersion. And here's a great example that I picked up from, I don't think it's in our textbook, but I picked up from another textbook. Let's take a look at the age of the first 6 presidents when they were inaugurated versus the age of the last 6 presidents when they were inaugurated. And you'll see the first 6 presidents, and I can't name them. Let's see, Washington, I think it's Adams, then Jefferson. Oh my goodness, I'm terrible. But anyways, those are the first 6 presidents. The last 6 presidents, I'm not recalling where we're starting from here. This might be George H.W. Bush. This might be Bill Clinton, George W., Barack Obama, Donald Trump, and the current president, Biden. I believe that's correct. And you'll notice, if I calculate the mean, look how close they are. Okay, this one is almost 58. This one is almost 60. They're really pretty close. But when I calculate the standard deviation, how spread out, okay, how far on average is each observation from the mean? On average, each of these ages are about 1.6 years from the mean of 57.8. That's a pretty tight group of data. They're all clustered together. Over here, on average, the ages of these presidents are 13 years away from the mean of approximately 60. Okay, that's a lot of spread. Okay, that's a lot of spread in the last 6 presidents' ages versus the first six presidents' ages, when they have the identical or very close to the identical mean. They have a mean that's very close. Okay? So that gives you a sense of what those two things are doing. Population standard deviation, of course, it's population. It's a parameter. We use Greek letters, and we're going to use sigma for the population standard deviation. Sample standard deviation. Sample is goes with statistics. Okay. Sample is about statistics, and we're going to indicate that with a lowercase s, the statistic that goes with the sample. The standard deviation is not resistant. If we put in an extreme value, it will change the standard deviation. Okay, I'm sure that you'll notice the extreme values changed and we changed the standard deviation. It is not resistant. Okay, it can be changed. There's a lot of, well, let's go to that. How do you calculate this thing, this standard deviation? All right, well, the population standard deviation, again, it is sigma. It is a Greek letter because it is a parameter. It is equal to the square root of the sum of the square deviations about the population mean, which is mu, because again, it's a Greek letter for a parameter, divided by the number of observations in the population, which is the population size, the letter n. Basically, you're finding the difference between the observation and the mean. You're then squaring them all, adding them up, and dividing them by the number and taking the square root of all of that. That's what this is showing here, and that is giving you the population standard deviation. It's a lot of math. It takes some time to do it. Don't worry, we're not going to do it. We're not going to do it. But we just need to understand where it's coming from and what it means. For a sample standard deviation represented by the letter S, lowercase, it's the same idea, the square root of the sum of the square deviations about the, oops, I goofed. This should say sample mean, which is X bar, divided by, I'm not so sure why they divide by n minus 1. I'd have to go back and research that. But you divide by n minus 1, where n is the sample size. Here it is, same idea, except it's n minus 1, not n, and the same idea here as well. Okay, so a lot of math behind that. We're going to let technology take care of this for us. We're not going to memorize or work with this. It's just a lot of do the same thing over and over again. We're going to let StatCrunch find the standard deviations for us. Okay. Finally, our third measure of dispersion is the variance. It's the average of the square differences from the mean. All right. Basically what it is, I went down too quickly. Basically what it is this part right here, what's underneath the radical. The radicand, the value under the radical of the standard deviation. So basically you calculate the variance first. You take the square root of the variance and you get the standard deviation. Okay, or if you've calculated the standard deviation, you square it and you get the variance. Depends on what you've calculated. If you're doing it mathematically, you would calculate the variance first and then you would take the square root. Population variance is indicated with sigma squared for a population. Sample variance is indicated with lower s squared for a sample. As with the other two, it is not resistant. Extreme values have an effect on the deviation from the mean. Is it not a resistant value? Okay, so the difference between these two. And there are other differences that get more complicated. I try to keep this table more simple for our class. Standard deviation in the left column, variance in the right column. The key one is probably here. The standard deviation is expressed in the same units as the data in the observation, whereas the variance is expressed in square units that are different from the units of the original data set. This is more useful to describe the variability of the data, more useful kind of statistically. This is more useful mathematically. Real-world application, population sampling, identifying outliers, real-world applications, statistical formulas, and finance. We're really going to be sticking here. It has more use, particularly because the units are the same as in the observation. It has more use to us in our statistics class. But we're just going to note that there's also variance, and we may speak to it again here and there in the class, but we're really going to be here. So we want to kind of put a star. We're going to focus on the standard deviation. Okay, so how does StatCrunch do this for us? Because we don't want to do it. Let's take a look at an example, and we're going to go into StatCrunch and have it do the math. Yeehaw. All right. Use StatCrunch to find sample, range, standard deviation, and variance for the traditional data set in 3_1_19. We find it with stat, summary, stats, columns. Okay. Note, when we're dealing with a sample, the defaults will give us the results for variance and standard deviation. When we're dealing with a population, we have to use the unadjusted variance and the unadjusted standard deviation. So StatCrunch is adjusting the variance and the standard deviation to give us the sample, the data for the sample, which is the default, because most things in statistics deal with samples. If we want to see population, we have to go to the unadjusted versions of those two things. So let's take a look. We're going to find the sample. So we're going to want to look at variance and standard deviation, the defaults when we get there. And I'll show you both. Whoops, kind of make my desk a mess here. Sorry about that. Let's see here. All right. So let's go to chapter 3. We're in 3_1_19 here. And we're going to look at the traditional data set. Again, this was classrooms, traditional classroom versus flipped classroom. That's the data set. We're not concerned about that. We want to find the range, the standard deviation, and the variance. So we're going to go to stat, summary stats, and we're going to go to they're in the column. So we're going to choose columns. Select the column. We're looking at the traditional data set. Okay, now again, notice we notice we have the statistics here. We have 11 items that have been selected. They've been defaulted. Here they are. Okay, here's my variance. It's a sample variance, and here's the standard deviation. It's a sample standard deviation. Okay, so if I go into here and say compute, here we have it. Okay, the range is 29.1. The standard deviation is 8.84 when I round it to the 100th. And the variance, which is the standard deviation squared, is 78.08 when I round it. We'll note that in just a second. Let's go back to options and edit. If you go into statistics, you'll notice as I scroll down, there is the unadjusted variance and the unadjusted standard deviation. I'm going to select those two and go back to compute. And over here, I now have the population. If it were a population, this would give me the population data. Okay, this was a sample of scores, but when you're doing things with population and you want the variance of the standard deviation, you need to select the unadjusted version of that. So go back to our sheet because we were asked a question. Okay, the range. Well, the range for our sample, again, we talk about a sample. The range is 229.1. Our standard deviation, I tend to abbreviate that with SD, is 8.84. And our variance is 78.08. There you go. Had it said population, we'd want to take a look at the unadjusted variance and the unadjusted standard deviation.